In this video, we're going to do an application of linear programming, and the application is going to have to do with raising geese and goats. So as an example, a 4-H club member raises geese and goats. She wants to raise no more than 16 animals, including no more than 10 geese. She spends $25 to raise a goose and $75 to raise a goat, and she has $900 available for the project. Find the maximum profit she can make if each goose produces a profit of $14 and each goat a profit of $40. Okay, now I've made a little table here. We're going to label X as the number of geese and Y as the number of goats. Okay, and this table summarizes some of the information up there that I read. Now, a couple things that were given. She wants to raise no more than 16 animals. So what that means is we want X plus Y to be less than or equal to 16. Okay, including no more than 10 geese. So geese, remember, is X, so we want X to be less than or equal to 10. It says that she spends $25 to raise a goose and $75 to raise a goat, and she has $900 available for the project. So her costs are going to be $25 times the number of geese, that would be X, plus $75 times the number of goats, that would be Y, and that has to be less than or equal to $900. Okay? And finally, one other piece of information that's not really stated up here, but it's kind of obvious. X cannot be less than 0. X has to be greater than or equal to 0. The number of geese and the number of goats has to be greater than or equal to 0 as well. Okay, now what we want to do is maximize the profit function. Now the profit that she would make would be 14x plus 40y, and we usually call the profit function z. So we'll say z equals 14x plus 40y. That's the function that we're trying to maximize. We want to maximize this subject to all these constraints up here. Okay, this is called the objective function. Okay, the objective function is the thing that we're trying to maximize. We want to maximize the profit subject to all these constraints. Okay, now we're going to graph the feasible region, but before we do that, let's change these functions to make them easier to graph. So for example, x plus y is less than or equal to 16. Let's write it as x plus y is less than or equal to 16. If we subtract x from both sides, we get y is less than or equal to negative x plus 16. So we're going to graph y equals negative x plus 16. And the other one, 25x plus 75y equals 900. Let's divide both sides of that function by 25. And what we're going to get is that we have x plus 3y is less than or equal to 900 divided by 25, I believe that's 36. Subtract x from both sides, we get 3y is less than or equal to negative x plus 36. And finally, divide both sides by 3. Okay, so we get y is less than or equal to negative 1/3 x plus 12. 36 over 3 is 12. Okay, so we have this function here, this one here, and let's not forget our original functions that x has to be less than 10, or I'm sorry, inequalities, not functions. X has to be less than or equal to 10, and x and y have to be greater than or equal to 0. Okay, well, to say that x is less than or equal to 10, we can draw in our equation here, and at x equals 10 is this vertical line, so x less than 10 would be everything to the left of this line, 10. Now, y equals negative x plus 16, that's this line. Okay, has a slope of negative 1 and a y-intercept of 16. And to say that y is less than that means that we would shade underneath that line. Okay, and also y equals negative 1/3 x plus 12, that's this line right here. And to say that y is less than that means that we'd be shading underneath it. Now also to say that x is greater than 0 means we'll shade to the right of the y-axis. And to say that y is greater than 0 means we will shade above the x-axis. Okay, and the region that you get, the feasible region, is all of this in here. Okay, this region is the region that satisfies all those properties. Now, I didn't draw in blue the line x equals 0 or the line y equals 0, but I could have. Okay, so this is the feasible region. Now, what we want to do, remember, is maximize our objective function, and our objective function was 14x plus 40y, subject to the constraints that x is greater than or equal to 0, y is greater than or equal to 0, x is less than or equal to 10, y is less than or equal to negative 1/3 x plus 12, and also y is less than negative x plus 16, less than or equal to negative x plus 16. Okay, so we have these 5 constraints here and one objective function, that profit function that we're trying to maximize. Now remember, with linear programming, if we want to maximize that profit function on this region, this feasible region, what we're going to have to do is the maximum will occur at one of these corner points. Now this point here is the point 0, 0. This point is 10, 0, and this point is 0, 12. Okay, those points are kind of obvious. So let's write these down. We have 0, 0, 10, 0, and 0, 12. Okay, but what about these points right here, P and Q? Well, Q, we can figure this one out without too much trouble because the first coordinate there has to be 10 because it's directly above this line here. What's the second coordinate? Well, remember this line is y equals negative x plus 16. So if we put 10 in for x, y would be 6. Okay, because it's on this line here and it's on this line. So x is 10. Means it's on this line. And if we plug in 10 for x here, we get y is 6. Okay, now what about this point? Well, this is on the intersection of these two lines, this line and this line. So how do we find P? We have to solve that system of equations, this equation and this equation. So how would we solve y equals negative x plus 16 and y equals negative 1/3 x plus 12? Well, we would set negative x plus 16 equal to negative 1/3 x plus 12. Okay, now to get all the x's on one side, we could add x to both sides, and we can subtract 12 from both sides to get all the constants on the other side. Notice these would cancel and these would cancel. We'd be left with 4 on the left side, and we'd have negative 1/3 x plus 1x. That would give us 2/3 x. Okay, it's kind of like negative 1/3 x plus 3/3 would give you 2/3. Okay, and finally what you can do to get rid of the 2/3 is multiply both sides by 3/2. Okay, then you would just get x is equal to 4 times 3/2. Well, 4 times 3/2 would be 6. Okay, 4 times 3 is 12 divided by 2 is 6. So x equals 6. What that tells us is that the first coordinate here of this point is 6. And the second coordinate, well, you could plug it into either one of these equations, but let's try this one here. If we plug in 6 here for x, y would be 10. Okay, so our other point P is 6, 10. Okay, so what we have is 10, 6 and 6, 10. Okay, so our maximum has to occur at one of those 5 points. Okay, now how do we figure out what the maximum is? Well, we take our objective function, 14x plus 40y, and we plug in those 5 corner points that we found. And so I did. Now 0, 0, if you plug in 0 for x and 0 for y, z is going to be 0. If you plug in 0 for x and 12 for y, you get 168. What that means is that if she raised 0 geese and 12 goats, then her profit would be $168. Okay, and if she raised 10 geese and 0 goats, her profit would be $70. Okay, now which one of these is the greatest? Well, this one right here. Okay, so she should raise 6 geese and 10 goats. That will give her the maximum profit, and that profit would be $182. Okay, so remember the question was find the maximum profit she can make if each goose produces a profit of $14 and each goat a profit of $40. So what we can say is that the maximum profit would be $182.